On this video, we're going to talk about what if once I factor out the denominator, there's some repeating terms, repeating factors. So let's looking at this example. Because my numerator has degree 4 and my denominator has a degree 3, so first thing first, I need to do the long division first. So I'm going to divide the numerator and the denominator, and then I got x plus 1 as my dividend, and then 4x as my remainder. Then when I factor out x cubed minus x squared minus x plus 1, I will factor it by grouping, which is going to be grouping the x cubed minus x squared, factor out the x squared, and grouping the minus x plus 1, factor out the negative 1, and then I ended up with x squared minus 1 times x minus 1, where x squared minus 1 can be continue factored as x minus 1, x plus 1. And you can see that we have x minus 1 twice. So I can rewrite it as x plus 1 times x minus 1 squared. So because I have a repeated factor, x minus 1 squared, I need to take this one into considerations. That means I can have something over x minus 1 plus something over x minus 1 squared to get this 4x over x minus 1 squared. So just let's looking at this partial fraction decomposition. So I'm going to write it as a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. So I need to considering every single power for the factors. And for the a over x minus 1 is missing an x minus 1 and x plus 1. For b over x minus 1 squared is only missing an x plus 1. For c over x plus 1 is missing an x minus 1 squared. And those are the terms I'm going to multiply to my a, b, and c, and only considering the numerator because the denominator is always x minus 1 squared times x plus 1. And then I will use my trick again. I'm going to let x equals to 1, then x minus 1 will equal to 0. In this version, I'm able to eliminating a and c. To get 4 equals to 2b. And b is equal to 2. Now I can do the similar thing by setting x equals to negative 1. Then x plus 1 equal to 0. In this version, I'm able to eliminating a and b. So I got negative 4 equals to 4c because negative 2 squared. C is equal to negative 1. However, because of x minus 1 squared, there's no other terms I can eliminate. So for this case, or for the third one to find my a, I'm going to plug in b equal to 2, c equal to negative 1, and I'm going to pick x to be anything. The easiest thing I will pick is either 0, 1, or negative 1. Since I haven't used 0 yet, so I'm going to let x equal to 0. Plug in b equal to 2 and c equal to negative 1. Then 4 times 0 is going to be 0 equals to a times 0 minus 1 times 0 plus 1 plus 2, which is the b, times 0 plus 1 plus negative 1, which is the c, times 0 minus 1 squared. Which I got negative 0 equal to negative a plus 2 minus 1. So a is equals to 1. Now I got my ABC. I can go back to the original prop or original setup to have the integral of 4 x squared x to the fourth minus 2x squared plus 4x plus 1 over x third minus x squared minus x plus 1 dx is equals to the integral of the part from the long division x plus 1 plus from the partial fraction decomposition a over x minus 1, a is 1, plus b over x minus 1 squared, where b is 2, plus c over x plus 1, which is c is negative 1. And now every single term is easy to integrate. So the antiderivative of x is going to be x squared over 2. Antiderivative of 1 is x. Antiderivative 1 over x minus 1 is just ln of x minus 1 with absolute value sign. But the antiderivative of 2 over x minus 1 squared is a little bit tricky. So we're going to we have to let u equal to x minus 1 and using the u sub to find it, which is negative 2 over x minus 1. And then the antiderivative of negative 1 over x plus 1 is just the ln. Because we have two ln's, they are doing subtraction, we can combine them using division. This is the property of log. And that is our final answer for this particular problem. So from 2 over x minus 1 squared, we're using the u sub. And u equal to x minus 1, then du is just dx. And using the power rule, it's going to be 1 over negative 2 plus 1 times x minus 1 or the u to the negative 2 plus 1. And that is how we got negative 2 over x minus 1.